iRobot has a fairly extensive use of CGI. In the past, computer graphics have been used in movies to create environments, landscapes, all kinds of things. More and more we're seeing computer graphics used to create characters. And iRobot, I think, really sort of pushes the envelope on that particular use of CGI. One of our main characters is actually computer generated in this movie. And for me, what's interesting about that particular use of visual effects is it suddenly goes away from being purely a technical exercise and becomes more about character and emotion, which I think is what good movies are all about. In this film, I think we're definitely pushing the envelope with that idea and trying to create a fully realised character via computer.
You're seeing full concept illustration, and this is the first vision of the exterior world. It was way more futuristic in some ways. We started the project about a year and a half ago. I got the script and it felt very dark. That was the first pass, Jeff Winter, and I liked that. And when I read the script, I thought, wow, that's Alex, period. And then I called him the next day and I said, hey Alex, this is cool, man. This is exactly the kind of... He said, well, I'm going to stop you right there. This is not going to be like Dark City or The Crow. I want something completely different this time. I want a movie with blue sky, real, documentary of the future. I said, wow, that's a surprise. And I started to design for him for a while on taking that direction, which was very stark futuristic, using Calatrava design, the type of stuff that those big architects do now. We were supposed to shoot it in Sydney, and we ended up being in Vancouver after a while. We both came here and looked at the place, and the thing became more textured, less slick. The great thing, though, is I think we stopped at the right place, where you have grunge in a movie, dark thing, but you also have bright plaza USR world, which is very pristine, very stark, very simple, not over busy or anything. Yeah. This is new for me because I haven't really done that type of futuristic stuff before. It was very much fantasy oriented before. This time, Alex wanted to be much more realistic, and that's the path we're following. I mean, there's some very wild sets, there's some very wild moments. You know, obviously the robots are very futuristic, but at the same time, some of our sets are trying to anchor very much in reality. So it's a new take for me. I haven't done something like that before. Wow, this is just the concept things, early concept. We finally decided that the city this thing was happening in was Chicago. For the longest time, we had no idea. This was a generic city somewhere. We talked about LA, we talked about New York, and basically they figured out that it should be Chicago.
You know, there's a couple of key scenes in iRobot that are laser scanned. It's a crew that takes equipment out that basically can recreate an environment in a computer. So it's kind of like creating a 3D model based on a real environment. And then you can light it however you want to. So in this instance, they went and stood at the crossroads of a major intersection in Chicago and captured the entire environment on computer. So now we can, in the movie, we can have a scene where dozens of computer-generated semi-trailers drive up and hundreds of robots spill out in this major intersection in Chicago. To get the permission to actually shoot something like that would be impossible. There's no way you could shut down that intersection, you know, however much money you chose to throw at the city.
So the first thing we did is we took a map of Chicago and started to create our own geography in there. Where does Spooner live? Where is the USR building? Do we see the Sears Tower as a iconic element in there from the... Yes, we do. It's there. Granny. And then when you start doing this, for the director, for everyone, it's a lot simpler to understand the action, the timing and everything, you know, when someone goes to somebody else's house. That's what we did. What you're seeing next to this is also what kind of interesting structure we find here in Vancouver that would be futuristic and feel like our world. And there is a few of them. They are very isolated, one here and there, and not everything was pleasing to us. So obviously you're going to have a lot of CGI behind this, of enhanced building. But there was a few locations like those places which were really, really good for us. Plus we go through the regular, reference material, and we dig for tons of magazines, of architectural magazines, to get more of that material and start putting a package for Alex to kind of react to. Part of the geography of the city, like the suburbs, are grungier. I wouldn't say grungier, they're more as we know them today, and the big impact of the futuristic world has come into the downtown area, where now you have very nice, sleek plazas, you know, everything is white, beautiful, well, white, you know, light color.
Gardens.
And when the more you spread to the suburb, the less of that impact happens, and then you see more and more of the buildings as we know them today. Spoonerville is actually, what I wanted design was to create is a sense of the big power being disrespectful of those places. For example, there's a tram system that goes all around the city. In the downtown, it's in a very beautiful strategic place. It's gorgeous, it fits the landscape. In Spoonerville, it's in the middle of the street. Those pillars that used to be very organized on the downtown are totally out of place, and they're just there, and they just stop in the middle of a building. They're probably going to go in the middle of a building, in the middle of a street. There's a total disrespect. This is how Spoonerville is. And the city itself, I mean, the storefront, for example, you have a mix of modern, futuristic, old. It's all mixed up together. The people, the crowd is the same. It's a mix of like businessmen that are just going to go by there just to meet people or whatever, and then you have these homeless people there. You want to feel that into the architecture as well. And I end up being into this location, which is probably one of our biggest built, exterior build as a location. This entire block you're seeing here is going to be transformed into a futuristic city. You're seeing here and there, you're seeing some of those street dressing elements. This is a big elevator that takes you to the parkways, the underground tunnel structure. We're building two of those gigantic glass structures. Also going to keep a lot of those real store in between. So again, this is that mix of future and everyday life kind of thing.
We tried to put ourselves in the mind space of the people designing the robots in the movie, in that world. And we figured that they would be making creatures that we would feel comfortable having in our homes, comfortable around our kids, our family, doing errands, doing whatever it is that robots will, I think, be doing for us in the future.
We started to go in any direction possible. First of all, for me, I had to do that to see where Alex would feel comfortable with. So I went into some extremely hardware robots, some very weird robots, bunch of different directions. I had to keep in mind, though, that those robots were sold to the people in the street, so they should not be too freaky. They could not be too cute either, because the time they turn around, they don't morph. They stay the same thing, but they have to suddenly become scary.
It is about a question of making them familiar, making people feel comfortable with them. And again, it feeds right back into Asimov's laws, which is about safety. It's about feeling secure in the knowledge that the robots can't turn on you and hurt you in any way.
The face is basically three levels. There's the mechanics on the inside. Then you have an underskull. On top of the skull is a soft skin, which is some kind of futuristic silicone in some ways. So if you touch him, he's soft. But behind that is a clear skeleton. So that's how you create all the layers. On that clear skeleton, you have parts, elements, you know, like chips, wires, and all that stuff. Just make it work. So it gives you many, many layers. At the same time, you're not blocking out all the transparency with a fake opaque material. That's why it's clear on the inside as well. Same thing for the chest. When that stuff was done, we started to create a robot in the computer based on those proportions and develop it and then start machining the part, like I was telling you, to create the actual lighting dummy and the hero one. From that point, that data was sent to CGI people to create the animated one.
What if you went more with a negative curve?
Going out?
Like that, yeah.
This is just the early stages.
Okay.
This is his inners. You can turn on his outer. We're working on putting mechanics up in his brow. I've got legs down here too. Oh, and this is something that Patrick designed.
Patrick did this?
Patrick did design some of these interiors, yeah.
Sonny is such a ephemeral character, and he's so subjective from scene to scene, and it takes you a long time to get to the point where you know what he should look like, because you light him a little differently, and suddenly he looks completely different, and it's not just a matter of me knowing what I want him to look like and liking a certain look. There's an army of people who all have to know that, because they're the people who are making Sonny.
Another thing that just sort of came on its own when I was drawing it, I decided to kind of like replace mechanics by futuristic muscles. I thought that would make it, in some weird way, very human, and also to a little extent, a tiny bit disturbing as well, because it's almost like someone you took the skin off, like those like weird figures in laboratories. So that sort of became an appealing thing to Alex, and we went in that direction quickly and developed the muscle idea. Just to say that what I think the two important things about Sonny beyond the character, where I'm not really stepping in, I'm really taking care of the design, was the transparency, the sense of fashion, and also the very closeness of the human being on creating muscle rather than bolts. And that was, for me, that were all the key things that made me design that thing at the end. What you're seeing in the script, again, is that this thing can be very scary or very beautiful and angelic in some ways. What transparency does for us, and that's some of the thing I was thinking about at the beginning, is saying, we're in the interrogation room. There is the typical top light. The robot is backing up like this. You see the front of the face lit. You don't see, and this is actually a real physical thing that works in real life. You see just the outside of the face lit. If he brings in the head underneath the light, suddenly you're seeing all the inside of the head. So this figure could be very beautiful, angelic, can become suddenly this weird mechanical thing.
Alan is the soul of Sonny, as much as any regular actor appearing on film in the usual way that we know and understand. At the moment we're animating Sonny, and we're comparing the tiniest nuance that Alan makes on screen. We're analysing him to the frame and trying to have Sonny copy exactly what Alan has created, because Alan has created a great performance. I mean, he's really put it on film, and now my responsibility is to carry that through into the CG character.
This is this take. I don't like the recoil being so slow, as if I'm preoccupied with the recoil and not what's happening in the room. These two people have scared me. I've hid. I've now jumped out because I can't hide anymore. He's about to find me. I lose it. I thought coming in and getting a chance to look at the performance and redo it, I would have an opportunity to take what I did and improve upon it. Any mistakes I felt I made, I could hone the performance, but I was at the height of robot training when we shot this. Now I'm not.
The way I tried to equate it to everyone was, think of it as an elaborate makeup effect.
I am unique.
Alan, in this case, is the soul of that character. He's the one that's created the performance, and I've directed Alan, and I continue directing Sonny now, But there's certainly no way we could have created Sonny without a real human actor behind the character.
The main factor for us going with miniatures in this sequence is that there's such a high level of interaction. We have got a robot that has to create all this destruction. We've got the entire infrastructure, the architectural components of the house collapsing, and that's just such an organic process. The next step in this game is to get the automatic trigger position.
The biggest challenge in any one of these things is to make it believable. That's perhaps a bit of an overstatement, but the thing about what you're trying to achieve here is you've got to make the audience believe that your hero is really in danger. And that's the mantra for this particular sequence. Will Smith, the Spooner character, has to be in danger, in jeopardy of losing his life in every frame of the sequence.
We've got this live action shot and the camera's doing a particular move. I'm scaling that to 1/4 scale on our miniature. Even a small mismatch in position can throw the perspective out. So you have to really pay attention to the details. There's a lot of interaction and a lot of people involved in the process.
Will Smith is running through a building that's being destroyed by a giant robot. And we've got all these things splintering and falling, and dust and mortar and chairs flying through the air and pictures being knocked off the wall. To do all that in computer graphics would be an incredibly complex task.
I'm going to airbrush the floor in this area to generate sort of a synthetic shadow, just so that we can try to match the set a little bit better. They had a bit more control over their lighting than we did because of what we're having to do here. So I'm just going to generate a false shadow, then we bring in our breakaway walls, dress those to camera, and then we're good to go.
And action! Cut, back to ones, please.
If you think about the world and what lights the world are lights of a given size. And when you're dealing in a miniature world, all the lights are too big, because they're all 10 times, or in this case 4 times too big. So you have to kind of cheat that and make that look like the lights are appropriate size. In the case of this shot, the difficulty here lies in the fact that it's being combined with a live action shot. a shot that was done months ago with the actors by the first unit. This shot has to join to it, and actually they're going to put the two pieces of film together, composite them electronically. And so I have to anticipate the problems of putting them together and try to make that go smoothly.
You get control when you use computer graphics to a certain extent. When you're working with a miniature, you bust it up, it falls the way that it falls, and you have to live with it and go on to take two if you don't like it. But one thing you do get from using miniatures or any kind of model photography is it's real.
Good. So your hands are just kind of loose, but what you need to be is you're going to walk up here and you're going to go whatever. They need to be alive. Well, you have to.
French thinking about it. Hey, Paul, it's not working.
If I was going to invent a robot in the year 2035, what would I do in terms of how would I base their movement? And I just thought I would base them on a dancing Tai Chi master. You know, ballet or dance is really the ultimate form of body control and movement. Tai Chi is all about flow, energy, and balance, as is dance. And so I really just took the idea that robots that needed to be 100% concerned with their weight and their balance. You can use your hands as well to help you walk. So feel like you're wading through a pool that's, you know, up to your weight. Flat foot. Ready? Anyone doing NS5 should be here. I was sitting down at a bar in town one day and this girl walked past and she was walking exactly like an NS4. She was tired, she was walking uphill and she was carrying something. But it was exactly the NS4 gait and the whole thing. So I kind of felt happy, proud and vindicated that, you know, how they move is not necessarily completely different to how a human would. Okay, so there's this element that you're pushing. So your body, again, you should be forward. We don't want any extra movement. So when you're walking, there's no hips, shoulders. If you stop and stand still, there's no kind of any extra kind of movement. Once you walk and you stop.
We did quite a bit of motion capture on this show, and we've referred to it commonly as mocap. What it entails is we set up a grid on the floor to give the actors kind of a starting point. What this grid does is it tells us exactly where these actors are in space and relative to some of the sets or something that they might have interacted with. You have all of these cameras around the grid, which are infrared cameras that we use the motion analysis system with the Eagle cameras for this particular shoot, and it has an extremely high definition range, so it can pick up so many lines of resolution. The whole process is that these actors walk around with these little, they look like ping pong balls, but they're reflective balls, they're little markers all over the suit, and those cameras reflect light. Each camera has its own light source around the lens, and it shoots out light that's specific to that camera. Each camera only sees the light that comes out of its own lens. And as each camera sees the same balls but in different perspectives to where the camera's positioned, then all that data gets fed into the computer, and the computer triangulates exactly where each one of those markers is. So this marker, it can tell that this marker is on this shoulder and this marker is on the elbow, this one's his arm, just by triangulating among all these cameras.
Some sections of movement I've just redone. Now, okay, we filmed it once. Let's say, film me picking up something, running, stopping, and putting it down. We watch on the monitor, see how it's done. Okay, great. It took you 2 seconds from the time you turn to pick up the thing, you run for 5 seconds, you set it down immediately. And I have to match that action with a motion capture suit.
3, 2, 1, action.
You were startled by a jack in the box.
Duh!
Deactivate.
Let him go.
It's not going to hurt us. I gave you an order.
He's not listening right now, lady.
Vicky, seal the lab.
Command confirmed.
Cut it.
We figure out exactly what the performer skeleton was doing, what his bone structure was doing, and then we need to map that onto our robot bone structure, which is completely different. So the robot obviously has slighter hips, longer legs, a narrower shoulder base, His shoulders are a little bit more rigid in movement. His chest is more rigid in movement. His spine, his 3 joints in his lower spine are much more flexible. And all of that needs to be incorporated into the motion. So then they use this software, the motion analysis software, to map, the human character bones onto these guys' bones, the skeleton for the robot.
We can shade it so it's all gray, but I'll put it on.
Shade it all gray.
Do you want to?
A puppeteer is used to using certain things to control a puppet to move, and we call our animation characters a puppet too. And we have certain controls to like just pick and select, and you can grab and move the arm around. You don't have to worry about rotating this and then rotating this and then rotating the wrist and then rotating the fingers. We have all these series of controls to make it much quicker and much easier for the animators. And by putting the motion capture data onto those controls, it then puts it in the animations world, the animators world.
This is the internal skeleton inside the shaded robot. Okay. And so now we're going to make it move based on the markers, and then we'll just make that skeleton go onto the shaded robot, and voila, your shaded robot is moving.
He looks overweight.
Motion capture came out of the medical world, and it was used to figure out, joint data, and I guess help doctors figure out what's happening to the human body when it goes through these stressful things. So they needed realistic mappings or animations of what the body's doing and what all the joints are doing. Surprisingly, it found this whole other medium that started in the entertainment industry. It started in games, I believe, and then got into film, and now it's like, it's much bigger in entertainment than anything else.
Isaac Asimov's writing has influenced a generation, or probably countless generations of fans and also writers and scientists. I think it's interesting how many of his ideas have sort of been embraced by the scientific community. When we were developing this movie, we did a lot of research, tried to sort of study up on how real robots functioned and perhaps where they would perhaps one day go. One of the things we read was Ray Kurzweil's Age of the Spiritual Machine, which was a real eye-opener in terms of projecting into the future and trying to work out where things would eventually lead us.